The following question is about moles and electrolysis. And the question states in the commercial electrolysis of brine. Now, brine is concentrated. It's concentrated NaCl. Now, to answer this question, you need to have some idea about electrolysis. So you're basically dealing with the electrolysis of concentrated NaCl. And he's also already given you the products are chlorine, hydrogen, and sodium hydroxide. So that would make life easier for you. What the question states is, what is the maximum yield? Now, maximum yield is the theoretical calculation that you're going to do. Maximum yield is what you're going to calculate. Of each of the products, when 58.5 kilograms of sodium chloride are electrolyzed as brine. So the first thing we need to do is we need to figure out what is brine and what is the electrolysis of brine. So brine is concentrated NaCl. It's going to have sodium ions, it's going to have Cl ions, and it's also going to have H plus 1 and OH minus 1 ions. Now, at the anode, these two ions would be attracted at the anode. So let's separate the anode and the cathode by this dotted line. So at anode, since it's concentrated, so Cl would be discharged. Cl would lose one electron. It's going to lose one electron and it's going to produce Cl, but Cl is a diatomic molecule, so it's going to be Cl2, and to balance this equation, it would be half Cl2 molecule. On the other side, you have this is the cathode side, the negative electrode, positive ions are attracted. So on the other side, you have sodium ions, not sodium ions, in fact. Between sodium ions and H plus 1 has a higher tendency to get discharged. So H plus 1 would gain electrons and it would form a hydrogen atom, but since it's diatomic, it's going to combine with another hydrogen atom and form H2 molecule. Now, to balance this should be half H2 molecule. So your reaction, Cl is gone and H plus 1 is gone, and you're left with NaOH. Now, if you look at the products, what amount of NaOH is produced? The amount of NaOH that is produced in this reaction, that's exactly 1 mole of NaOH. And what is the amount of chlorine that is produced? It's half Cl2 produced. So half molecules of Cl2 are produced. And you have half molecules of H2 also being produced at the cathode. So these are your three products and the ratio. So for every 1 mole of NaOH, half molecules of Cl2 and half molecules of H2 are produced. So that's the ratio in which they are being produced. Now, coming back to the question, what the question states is that you originally had 58.5 kg of NaCl. Now, if you know, you can find the moles of NaCl. Moles of NaCl would be the mass of NaCl, which is 58.5 kilograms. So that's 10 to the power 3 divided by the molar mass of NaCl, which is also 58.5. So this would give you 1 into 10 raised power 3 moles. So you basically have 1 into 10 raised power 3 moles. So starting with 1 into 10 raised power 3 moles. So originally you had the amount of NaCl that you had was 1 into 10 raised to the power 3 moles of NaCl. Now the ratio is 1:1 because 1 NaCl, we started off with 1 NaCl, it ended up producing 1 NaOH. So if you started off with 1 into 10 raised to the power 3 moles of NaCl, the amount of NaOH is also going to be exactly the same, 1 into 10 raised to the power 3 moles of NaOH. The other thing would be, chlorine would be, according to the ratio, it would be half that amount. So it's going to become half into 10 raised to the power 3 moles of Cl2, and hydrogen would also be half into 10 raised to the power 3 moles of hydrogen. And the next thing is we need to find the mass. Now, to find the mass, molar mass, we need to multiply moles by the molar mass. So you need to multiply the moles by the molar mass. So if you multiply by the molar mass of NaOH, which is 40, so in terms of kg, this would be equal to 40 kilograms. And if I multiply it by the molar mass of chlorine, which is 71, then this would be, according in kgs, it's going to become equal to 35.5 kilograms. And if you multiply it by the molar mass of, hydrogen, which is 2, so moles multiplied by molar mass is equal to mass. So this would become exactly equal to 1 kg. So we're going to look for an answer where you get 40, 35.5 and 1 kg. So the correct option is going to be the yield of chlorine. That's going to be A, because you have 40 kgs of sodium hydroxide, 1 kg of hydrogen, and 35.5 kg of chlorine as your products if you have 1 into 10 to the power 3 moles of NaCl.